If z is real, then we have some relation like sin h inverse z is equal to log of z plus root of z square plus 1. Yesterday we did that for sine inverse z, no, sine inverse z, cos inverse z and all. So there I was here, I was there, then here plus or minus and like that it was. So but here sin h inverse z is equal to log of z plus root of z square plus 1. Then cos h inverse z, cos h inverse z is given by log of z plus under root of z square minus 1, and similarly tan h inverse z is equal to 1 by 2. Yesterday we had here I by 2 log of I plus z upon I minus z. Here it is half log 1 plus z upon 1 minus z. Okay, so now I will show you to prove one or two, the other one you have to do. That is, so here proof of this one. The first one I will show you. You need to do for cos. So here I will take, let sin h inverse z is equal to say y. Okay. Then this means that sin hy taken to this side, sin hy is equal to z. Sin h inverse z equal to y. Therefore sin hy, we took this to here and z will come on the right. It means by definition only. Then what we do here is, therefore z is equal to sin hy formula. We know sin hx is equal to e raised to x minus e raised to minus x divided by 2. This is the formula of sin h. Okay, so that only we will use here. So this will be e raised to y minus e raised to minus y divided by 2. Now again we will be using that quadratic form. So this is equal to e raised to y minus, this is negative. So what we will do, we will take that to the denominator, so that will become positive, divided by this 2. Okay, so before doing that, what I will do here, so multiply this 2 to the left side. So 2z is equal to e raised to y minus, this is 1 upon e raised to y. So 1 upon e raised to y. Now take the LCM here, or like in the previous question, means yesterday we did sin inverse z. So there what we did, we put some substitution for this e raised to y. So here also you can do like that. Otherwise you need to multiply this. Okay. So to avoid confusion, I will take here, put e raised to y is equal to say m. Therefore here 2z is equal to m minus 1 upon m. Now take the LCM here, so that is m square minus 1 divided by m, and here 2z will come. Okay, now multiply this m to the left side, so this will become 2z into m. So now just do bit arrangement here. So this is m square, take this to the right side. So it becomes minus 2z into m minus 1. We are taking this to the right side. So minus 1 will remain as it is, no change of sign. So only sign of 2z will change. Okay. So now this is a quadratic equation. So we know how to do this one. Therefore m is equal to, m is a variable, m equal to minus b plus or minus root of b square minus 4ac, that formula. So here a is 1, b is minus 2z, c is 1, minus 1. Okay. So that is minus b means minus, here b is minus 2z, minus b plus or minus under root of b square means minus 2z square, minus 4 into a is, so here if you need you can write a is 1, b is minus 2z. So we are comparing this with quadratic equation form. Okay, 2z and c is minus 1. So minus b square minus 4 into a is 1, c is minus 1. So this will become divided by 2 into a. So 2 into 1. So 2 into a. Therefore m is equal to minus minus plus 2z plus or minus under root of 4z square. Okay, 2z square is 4z square, then minus minus will become plus 4 divided by 2 into 1 is 2. Now this is equal to, here you can see 4 is common. So 2z plus or minus from the root, we are taking 4 here common, 4z square plus 1. And we are taking this 4 out of the square root, so it will become 2 here. Okay, so that is 2 into z square plus 1 divided by 2. Now take 2 as common factor and you can divide 2 throughout. Now when you take 2 common, it will become like this. Okay, so 2 into z plus or minus under root of z square plus 1 divided by 2. So that 2 and this 2 will get cancelled. Okay, so that this is here. So it is z plus or minus under root of z square plus 1 m. So this is m. Now here what is m? M is e raised to y. Okay, e raised to y is equal to z plus or minus under root of z square plus 1. Taking log on both sides, you will get log of e raised to y is equal to log of z. Now here we will put only the plus value, because if at all here when you take z minus, okay, z minus this one, if this is going to be a negative number, then you will get log of a negative number which is a complex number. Okay, we started with if z is real. If z is real, we started with that. So here we cannot take this minus here, because if at all while calculating, if you are getting that as a negative number, logarithm of a negative number is a complex number, so we will not take this one. Okay, so only plus will come. So plus. Then here log e raised to y is n log m. So y into log e will come. Log e is 1. Therefore y is equal to log of z plus root of z square plus 1. And what is y? Y is equal to, y is sin h inverse z. This one. Y is equal to sin h inverse z.